Hello, it's Keith here, and this is lesson 16 of the platform-specific series of my Z80 programming tutorials. Now, over the last few weeks, we've been looking at how to set the palette on a variety of systems, and this week we're going to be looking at the Sega Master System and the Sega Game Gear. As the same as in the other weeks, we're going to be using a CPC Plus style palette, which is one nibble per channel, and we're going to be converting it into the palette system required for the Master System and the Game Gear. Now, in general terms, the Master System and the Game Gear, as I've said before, are actually almost the same system. The Game Gear has a smaller screen, but in most cases, the hardware is identical. One rather unusual place where they're very different, though, is setting the colour palette. On the Sega Master System, each channel is defined by just 2 bits. On the Game Gear, it's actually defined by 4 bits. This is especially strange when you look at the successor, the 16-bit Mega Drive or Genesis, which only uses 3 bits per channel. So the Game Gear has a larger colour palette than its 16-bit successor, which is very strange, but in terms of actually programming things, all we need to do is do a slight change to the code to define the palette, and then we can work fine. So it's not a major problem writing code for both systems, and the example code we're looking at today, which is the same example code as we've seen on all other systems, is almost identical on both systems. We're just moving the top left hand corner slightly to account for the smaller screen, and the colour palettes are being defined slightly differently. So, well, how do we set colour palettes on the Master System and the Game Gear? Well, the first stage of the procedure is actually pretty much identical for both systems. Now, typically an address will be from 0 to 4000 because, in hexadecimal, because the system only has 16 kilobytes. But when you want to set a palette definition, you actually start the address with and C0 and then 2 address bytes. Now, this isn't really an address within the VDP memory because, as I say, the VDP only has 16 kilobytes and that is the top of a 64 kilobyte range. So it's actually kind of a virtual address, and it's just telling the VDP to use these definitions as the palette. Now, each palette has 16 colours on the Master System and the Game Gear, and there are 2 palettes available to us. The first is used by the tile map, and the second one is used by the sprites or the tile map. So we can't set the sprites to use the first palette, but the tile map can use either of the 2. This allows us to have up to 32 colours on screen. Each palette is defined by 16 colours though, and on the Sega Master System, each of those colours is just a single byte. However, on the Game Gear, because the palette definition is larger, we're using 2 bytes per location. So we do have to adjust slightly the memory location we're writing the new palette data to. On the Game Gear, we have to double the colour number we want to write to get the correct first byte of that colour definition, because each definition takes 2 bytes. So here you can see the format that we have to write the byte to the Master System in. The first 2 bits are unused, then there's 2 bits of the blue channel, 2 bits of the green channel, 2 bits of the red channel. On the Game Gear, we've got 4 bits per channel, the first 4 are unused, then we've got 4 bits of the blue, 4 bits of the green, and then 4 bits of the red. Now, the only slightly tricky thing here is our definition that we're using from the CPC Plus, which is the standard definition we're doing on all the systems, is in green, red, blue format, and this we need blue, green, red format. So we're going to have to swap some of the nibbles around, but nothing too tasking there. So, enough of the theory, let's have a look at our code. So in the previous weeks, we've been looking at the bitmap code. This is the bitmap test for Game Boy and Game Gear. This is slightly different because this uses tiles, but the effect is very similar, and this will work on any system that supports tile maps, including the MSX2 with the V990. And here you can see our palette definition, and this palette definition is the exact same one as we looked at on systems like the Amstrad CPC and the MSX2 and the Enterprise. So it's a very common format which will work on all of the systems here. So we're going to use these 15 here, and you can see each nibble is a different colour. Now, in exactly the same way as all the other times we've looked at this code, we're reading in 2 bytes, which are the definition of the colour channel. We're then setting A to the number of the colour channel we want to change, and we're calling this set palette command. So the palette command takes A as the colour number, HL as the new definition. And here is the code that's actually going to do the work on both the Sega Master System and the Sega Game Gear. Now, as I said, the first thing we have to do is on the Game Gear, we have to double the palette number, because while the bytes on the Master System will be from 0 to 16, they will be from 0 to 32 for the first 16 colours, because it's using 2 bytes per colour. So once we've got that, we can just set L to that colour number, which is now the byte location. We then set H to C0 because all of our colour addresses are from C000. And then we have two versions of the code, one for the Game Gear and one for the Master System. But really, it's very straightforward. So all we need to do is we need to take our green, red, blue format and convert it into blue, green, red format. So we do this by loading in the green and the red, and we just store that for later. So what we do here is we load in the green channel into A, and then we shift the 4 bits of the red channel into A as well, pushing them off the left hand side of the B register here, which we loaded in here, and this pushes them into the right hand side of what is now A. So we're creating this bit here. We then out that to the VDP data port, which will write that into the CRAM. The CRAM auto increments. So then all we need to do is output the remaining blue channel, which we've still got in C because we loaded it here. We just wipe out the top nibble, which we don't want because that will be the red channel, and then we write it to the VDP data port here. So that's the Sega Game Gear done. The Sega Master System is actually even easier. So all we need to do is take the top 2 bits of each channel and move them into a remaining register, and we're using D for this purpose here. So we take the top 2 bits of the red register, push them into A, then we take the top 2 bits of the blue channel, shift them to the left, which puts them into the correct position, or in the result we already had here, and store it back into D here. And then we do the same for the green channel, or in D again, and at this point the accumulator will have the top 2 bits of each channel in here. But of course, if we were only using the bottom 2 bits in a color definition, this would be kind of scaled down to black. So this is removing some of the detail, but it's only a very simple way of converting the color palette. But that's really all it takes to get the Game Gear and the Master System to cope with that CPC Plus format palette, and that's all you need to do to get your CPC Plus palette working on these systems as well. At this point, we've only got one system left. We're going to be having a look at the Game Boy and the Game Boy Color. Now, the Game Boy Color can take a very good color palette. We'll be looking at this 1 nibble per channel palette and converting it for the Game Boy Color. But the Game Boy Black and White, that's not really appropriate. The Black and White Game Boy can only do 4 shades of grey at the hardware level. So black, 2 shades of grey, and white, if you will, or green, if you want to call it that. So I did have some code that would actually convert the colours to those grayscales, but it didn't really make sense because you would often end up with 2 shades of the exact same green, whereas really on the Game Boy you want darkest, mid, second mid, and then lightest, or the other way around if you want a bright to dark screen. So we'll be looking at that next week, but that's it for this week. I hope you've enjoyed it. Please like and subscribe to my channel. We've got a lot more Master System Game Gear stuff coming in the future. We're going to be looking at sound over the next few weeks, so that's going to be something really quite interesting on all of these systems. I hope you've enjoyed today's lesson. I know it's quite a short one. Thanks for watching and goodbye.